Having seen map entered variable in one of the previous videos, let us see Quine McCluskey technique, which can be used to simplify a boolean expression. I suggest that you guys watch the video how to convert a decimal number into a binary number before watching this video. So here we are given a problem and we have to solve this using Quine McCluskey technique. So the output y is a function of a, b, c, d, 4 variables, with a being the MSB and d as the LSB. And the output is 1 for min term 0, 4, 5, 7, 8, 11, 12, 15. So the first step in Quine McCluskey technique is to write all the given min terms in its binary form. So let me create two columns. M represents the min term. A, B, C, D are your input variables. So the given min terms to us is 0, 4, 5, 7, 8, 11, 12 and 15. I hope that you guys have seen the video how to convert from decimal to binary, or you know how to convert a given decimal number into a binary number. So 0 will be 0, 0, 0, 0. 4 will be 0, 1, 0, 0. 5 will be 0, 1, 0, 1. 7 will be 0, 111. 8 will be 1, 000. 11 will be 1, 0, 1, 1. 12 will be 1, 1, 0, 0. And 15 will be 1, 1, 1 and 1. So the first step is done. Let us see what is the second step. In the second step, you have to group the minterms. While grouping, you have to see that each minterm in the group must have same number of ones, and you must arrange these groups in increasing order of number of ones. So let me write down the group in column G, and minterms will be M, and A, B, C, D are your input variables. So the least number of ones among the given minterms is there in minterm 0. That is, it does not contain any 1. So group 0 will have minterm 0 and ABCD will be 0, 0, 0, 0. So the next group is group 1. So it will have 4 and 8, because minterm 4 and minterm 8 contains only 1 ones in it. So 4 is 0, 1, 0, 0 and 8 is 1, 0, 0, 0. Next group 2 will have 5 and 12. So 5 is 0, 1, 0, 1. 12 is 1, 1, 0, 0. Group 3 will have 7, 11. 7 is 0 followed by 3 ones, and 11 is 1, 0, 1, 1. Group 4 will have 15, that is 4 ones. Having grouped the minterms based on the number of ones in it and arranging them in increasing order of number of ones, let us see what is the next step. So step 3 is we compare all minterms in group n with each of the minterms in group n plus 1 and if they differ by only one bit, then you write dash in that place to indicate that the variable is eliminated. So here you'll compare group 0 with group 1, group 1 with group 2, group 2 with group 3, and group 3 with group 4. So when I do that, I'll get a new combination of groups followed by new combination of grouped minterms, and input variables are A, B, C, D. I have to compare each of the minterm in group n with each of the minterm in group n plus 1. So I have to compare 0 with 4 and 0 with 8. When I compare 0 with 4, I can see A, C, D is 0 in minterm 0, and even in minterm 4, A, C, D is 0, 0, 0. Only B is getting changed from 0 to 1. So group 0 will be 0, 4. A, C, D were 0 and B was getting changed from 0 to 1. So I'll write dash to indicate that the variable is eliminated. Now after doing this, I have to put a check symbol next to the minterms. So 0 and 4. We'll see what is the importance of this check symbol in a little while. Next I have to compare minterm 0 with minterm 8. So when I compare 0 with 8, BCD is 0, 0, 0 in minterm 0 as well as minterm 8. Only A is getting changed from 0 to 1. So my next entry will be 0, 8. BCD is 0. A was getting changed from 0 to 1. So I'll write dash to indicate that the variable is eliminated. Now I have to put a check symbol next to 0 and 8. Since there is already a check symbol next to 0, I don't have to put it again. So I'll just put a check symbol next to 8. Now I have compared all minterms in group 0 with each of the minterms in group 1. So next I have to compare group 1 with group 2. So when I compare minterm 4 with minterm 5, I can see ABC is 0, 1, 0 in minterm 4 as well as in minterm 5. Only D is getting changed from 0 to 1. So my next group is group 1. First member will be 4, 5. ABC was 0, 1, 0. Only D was getting changed from 0 to 1. So I'll write dash. And I must put a check symbol next to 4 and 5. Next I have to compare 4 with 12. 4 is 0, 1, 0, 0. 12 is 1, 1, 0, 0. So BCD is 1, 0, 0 in minterm 4 as well as in minterm 12. So only A is getting changed from 0 to 1. So the next entry will be 4, 12. So BCD was 1, 0, 0 and A was getting changed from 0 to 1. So I'll write dash there. And I have to put a check symbol next to 12. Next I have to compare minterm 8 with minterm 5. I can see A is 1 in minterm 8 and A is 0 in minterm 5. B is 0 in minterm 8 and B is 1 in minterm 5. So these two, 8 and 5, differ by more than 1 bit. So you won't enter it in this new group. So next I have to compare minterm 8 with minterm 12. ACD is 100 in minterm 8 as well as in minterm 12. Only B is getting changed from 0 to 1. So my next entry in this group will be 8, 12 and ACD was 1, 0, 0. B was getting changed from 0 to 1. So I'll write dash in that place. I have to put a check symbol next to 8 and 12. Since it is already there, not putting it again. So we are done comparing group 1 with group 2. Next I have to compare group 2 with group 3. When I compare minterm 5 with minterm 7, I can see A, B, D is 0, 1, 1 in minterm 5 as well as in minterm 7. Only C is getting changed from 0 to 1. So in my next group, the first member will be 5, 7. ABD was 0, 1, 1 and C was getting changed from 0 to 1. So I'll write dash in that place and put a check symbol next to 5 and 7. Next I'll compare 5 with 11. A is 0 in 5, A is 1 in 11, B is 1 in 5 and B is 0 in 11. So these two minterms 5 and 11 differ by more than 1 bit. So I'm not entering in this group. So next I'll compare minterm 12 with minterm 7. C and D is 0 in minterm 12 whereas it is 1 in minterm 7. So these two differ by more than 1 bit. Next we will compare minterm 12 with minterm 11. C and D is 0, 0 in minterm 12 whereas it is 1, 1 in minterm 11. So these two minterm 12 and minterm 11 differ by more than 1 bit. So you're not entering it in this group. Next we will compare group 3 with group 4. When you compare minterm 7 and minterm 15, you can see that BCD is 1, 1, 1 in minterm 7 and also in minterm 15. Only A is getting changed from 0 to 1. So in the third group, the first member will be 7, 15 with BCD as 1, 1, 1. And since A was getting changed from 0 to 1, you'll be writing dash in that place. And you have to put a check symbol next to 7 and 15. Next you will compare minterm 11 with minterm 15. ACD is 1, 1, 1 in both minterm 11 and 15. Only B is getting changed from 0 to 1. So the next entry in this group will be 11, 15 with A, C, D as 1, 1, 1. And since B was getting changed from 0 to 1, you will write dash in that place. And you have to put a check symbol next to 11 and 15. Step 4 is I have to keep repeating step 3 until no further combination of minterm groups is possible. So this was the table that we got from step 3. And now again I have to compare group 0 with group 1, group 1 with group 2 and group 2 with group 3 until no further combination of minterm groups is possible. So once you have a dash, it is easy to compare because even the dash has to be in the same position while comparing two groups of minterms. That is, in the first group of minterm, if it is 0 dash 0 0, and in the second group, if one of the member is dash 0 0 1, then you can see that in the first place there is a 0 here and there is a dash here, and in the second place there is a dash here and there is a 0 here. So these two will be differing by more than 1 bit. So it is easier if we just compare the dash position to check if they differ by more than 1 bit or no. So as a result of comparing group 0 with group 1, group 1 with group 2 and group 2 with group 3, we will get a new group formed by new combination of minterms with input variables as A, B, C, D. First I have to compare 0, 4 with 4, 5. Now B is dash here and D is dash here. So these two differ by more than 1 bit. You can see that B is dash, B is 1, D is dash and D is 0. So you can see if we just start comparing it starting from the dash position, it will be easier for us to compare. So next I'll compare 0, 4 with 4, 12. B is dash and A is dash. So these two will be obviously differing by more than 1 bit. Next you will compare 0, 4 with 8, 12. B is dash here and B is dash here. CD is 0, 0 and CD is 0, 0 in both 0, 4 and 8, 12. Only A is getting changed from 0 to 1. So in group 0, the first member will be 0, 4, 8, 12. And B was already dash. CD were 0, 0. Only A was getting changed from 0 to 1. So you will write dash in that place and put a check symbol next to 0, 4 and 8, 12. Next you will compare 0, 8 with 4, 5. A is dash here and D is dash here. So these two will be obviously differing by more than 1 bit. Next you will compare 0, 8 with 4, 12. A is dash here, A is dash here, CD is 0, 0 and CD is 0, 0. Only B is getting changed from 0 to 1. So when you write 0, 8, 4, 12, it will be nothing but 0, 4, 8, 12, which is already present here. So you don't have to enter it again. You just put a check symbol next to 0, 8 and 4, 12. Next you will compare 0, 8 with 8, 12. A is dash here, B is dash here. So 0, 8 and 8, 12 will be differing by more than 1 bit. Next you will compare group 1 with group 2. When you compare 4, 5 with 5, 7, D is dash here whereas C is dash here. So these two will be differing by more than 1 bit. Next you will compare 4, 12 with 5, 7. So A is dash here and C is dash here. So 4, 12 and 5, 7 will be differing by more than 1 bit. Next you will compare 8, 12 with 5, 7. B is dash here and C is dash here. So 8, 12 and 5, 7 will be differing by more than 1 bit. Next you will compare group 2 with group 3. So when you compare 5, 7 with 7, 15, C is dash in 5, 7 whereas A is dash in 7, 15. So these two will differ by more than 1 bit. Next you will compare 5, 7 with 11, 15. C is dash here whereas B is dash here. So 5, 7 and 11, 15 will differ by more than 1 bit. So this is the table which you get as a result of step 4. If there were any other groups and you had any combination of minterms in that, then you are supposed to compare group 0 with group 1 and group 1 with group 2 and so on until no further combination of minterm groups were possible. So now step 4 is done. Step 5 is to draw the prime implicant table and simplify. So this prime implicant table will have 3 columns. Column 1 is prime implicant. Column 2 is the minterms which form this prime implicant, and column 3 are the minterms given to you in the problem. So in the problem we were given minterm 0, 4, 5, 7, 8, 11, 12 and 15. Now the next question is how to identify this prime implicant. So this is where your check symbol comes in handy. All those terms next to which you have not put a check symbol will be your prime implicants. So you can see next to 0 there is a check, next to 4 it is there, 8, 5, 12, 7, 11, 15. 0, 4, 0, 8, 4, 12, 8, 12. So you do not have a check symbol next to this term, this term, this term, this term, and this term. So there are 5 prime implicants. Now how do you write these prime implicants in terms of variables? So if there is a dash under a particular variable, then it means that the variable has been eliminated. And if there is a 0 under a particular variable, then you have to write the complement of the variable. If there is a 1 under a particular variable, then you just have to write the variable. So 0, 4, 8, 12 will be C bar, D bar. So this is 0, 4, 8 and 12. So next is 4 and 5. So this will be A bar, B, C bar. 5, 7 will be A bar, B, D. 7, 15 will be B, C, D. 11, 15 will be A, C, D. So these are your 5 prime implicants, and these are the minterms that form this prime implicants. Let us enter this in the prime implicant table. Next, you have to write a cross symbol below a particular minterm column which forms this prime implicant. So C bar, D bar is formed by 0, 4, 8 and 12. So under 0 you have to write a cross, under 4, under 8 and under 12. So next prime implicant was 4, 5. Next 5, 7. Next 7, 15. Next prime implicant will be 11, 15. Having constructed the prime implicant table, you have to simplify it. While simplifying, you have to keep in mind that you have to cover all these minterms using minimum number of prime implicants. To do that, you have 3 steps. Step 1 is circle all crosses which is present only once in a column. So 0 is present only once in this column, 4 is present twice, 5 is present twice, 7 is present twice, 8 is present only once, 11 is present only once, 12 is present only once and 15 is present twice. So step 1 is done. Step 2 is include the prime implicants which has cross enclosed in a circle symbol in its row. So it is present in this row and this row. So your output expression must have these prime implicants, that is C bar D bar or ACD, because there is no other way you can cover these minterms without selecting these prime implicants. So you have to select C bar D bar and ACD in order to cover 0, 8, 11 and 12. So now that 0, 8, 11 and 12 is covered, when you select a particular prime implicant, keep in mind that all the minterms that form the prime implicant also gets covered. So by selecting C bar D bar, you will cover 0, 4, 8 and 12. So minterm 4 is also covered. Similarly, by selecting ACD, minterm 11 and 15 is covered. So 15 is also covered. Now we are left with 5 and 7. The step 2 was done. Now step 3 says use minimum number of prime implicant and cover all remaining minterms. The remaining minterms are 5 and 7 and the remaining prime implicants are A bar, BC bar, A bar, BD and BCD. Now out of these 3 prime implicants, you have to select minimum number of prime implicants and try to cover 5 and 7. So if you select A bar, BC bar, only 5 gets covered. If you select BCD, only 7 gets covered. Whereas if you select A bar, BD, both 5 and 7 gets covered. So the output expression will have A bar, BD, which will cover minterm 5 and 7. So step 3 is also done and this is your final expression.